Okay, here's the question then. It's on geometric progressions, two parts to the question. Let's have a look at it then. I've summarized it here. Here's a GP, find the sum of the first 18 terms. Okay, so A. So here then, the first term is 100, isn't it? And the second term is 80. So AR is the second term, and that would be 80. Now if we do 2 divided by 1, we'll find out what R is, because the A's will cancel. This divided by this is equal to this divided by this. 80 over 100 is 0.8, so we can write that down straight away. So there's R, and we know A is 100, so we need to find the first 18 terms then. So use the formula, S18. R is less than 1, so we can write A 1 minus R to the n divided by 1 minus R. A is equal to 100, isn't it? So let's put that in as well. Okay, so what have we got then? We've got 100 times bracket 1 minus 0.8 to the power 18, close bracket, close that bracket, divided by bracket, 1 minus 0.8 is 0.2, bracket, equals 490.99 to the nearest integer is 491 to nearest integer, which is what we were asked to find it to the nearest whole number. Okay, good. So that's part A. Part B then, second term is minus 20 and the sum to infinity is 64. Second term is AR and that was equal to minus 20. The sum to infinity is equal to A over 1 minus R, and that was equal to 64. So let's put that down then. So A is equal to minus 20 over R, isn't it? And on this side we can move the 1 minus R up to be with the 64, and we can write 64 1 minus R is equal to A, isn't it? Because that's A there as well. So move the R up and we'll get a quadratic. Minus 20 is equal to 64. 1 minus R times R, move that from times to divide. Then a 4 is common. 5 and 16. So we've got minus 5 is equal to 16. And then expand this bracket, we get R minus R squared. So what have we got then? We've got minus 5, expand this bracket, 16R, minus 16R squared. Move this over then to become plus. Move this over to become minus. And there's a minus 5 there. There's nothing on this side now. Now this hopefully factorizes. Hope so. 5 ones it has to be. And 16 ones would be too big, and so would 8 twos, I think. But 4 fours, let's try 4 fours to start with. Here and here. Okay, minus 16, so that'd be minus and a plus. And I think that should do it. Let's just check it. 16R squared. Minus 20 plus 4 is minus 16R. And then plus times minus is a minus. 1 times 5 is 5. So we've got that. So that tells us what R is then. This one, when it's 0, R is equal to minus 1/4, isn't it? And this one tells us that R needs to be 5 over 4 to equal 0. So what can we now say? R is equal to minus 1/4. R equals 5 over quarters is not a valid solution, is it? because we used S infinity to get in the problem. It's not a valid solution, as S infinity requires R to be less than 1. It certainly requires that, and this is bigger than 1. Or equal to 1, but it's bigger than 1, isn't it? So that's fine. So we can put 2b that. There we go. There's the problem.